The winning number for a lottery is determined by picking 6 balls from a bowl filled with 49 balls numbered from 1 to 49. How many ways can 6 numbers be chosen? So I did not really know much about whether the order mattered or not, and I need to know whether the order matters, because if the order matters, I'm going to use a permutation, and if the order does not matter, I'm going to use a combination. So I went on Google. Let me show you. I'm guessing you guys can see my screen right now. And I Googled it, and it said, in Powerball, 5 white balls and 1 red ball are drawn. The white balls are numbered 1 through 69. The red are Powerball, blah, blah, blah. So you have to guess, among the first 5, the order doesn't matter. So I know that your book is thinking that they don't want the order to matter, because when I look in the answer key, they used combinations. So I don't expect you to know everything about the lottery, but we're going to say the order doesn't matter. So I was going to use my combinations formula, the old-fashioned way that I've taught it for the last 20 years. So I grab my formula, and I want to take a combination. Remember there's 49 balls, taking 6, they're going to do 6 at a time. So N is 49. R is how many you're taking at a time. And N minus R would be 49 minus 6, so that's 43. And then I started doing this in class. I wrote it out. That's a factorial symbol, by the way. Factorial means you go in descending order, 49 times 48. You think I'm going to write this all the way down to the end, but I'm not. I'm going to stop at 43 because I know this 43 factorial will cancel out the rest of these ones on the numerator. That's a 6. Hopefully you can see that this is a giant 1, so it cancels out. Now 6 factorial, let me get that one going. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. So the 6 and the 48 are easy for me to see that they cancel out. The 5 and the 45 seem easy to me to just cancel out. I don't want to get those mixed up. The 4 and the 44 could cancel out pretty easily. I don't see anything that's divisible by 3, but this 2 can go with this 46. And I can just put that in my calculator if I want to. 49 times 8 times 47 times 23 times 9 times 11 equals that. I have to divide out, there's that 1 3 left down there. And that matches the answer key right there. So this is the answer that they actually wanted. But then I wondered, I know that there's a key on my calculator that knows how to do some things with factorials. So I started looking on my calculator, and then I realized, well, that's not going to help you. So yeah, my buttons are, you can't even see them. It's above the multiplication symbol, and it's written in yellow. There's my permutations and there's my combinations on my calculator. So you might have it on your handheld calculator, but they also have it on Desmos. So I guess what I'm saying is we have these formulas, but we can just go to Desmos, can't we? We love to go to Desmos. I'm not going to be old and boring for too much longer here. I'm just going to show you how to go to Desmos. So I just found it on Desmos. Where did I find it? I went to functions and I searched around and I saw this one with the C. That's combinations where the order doesn't matter. I'm going to do one with permutations because if, oh, what am I doing? I just want a new line. If the order didn't, or if the order did matter, like on how they drew the balls out, like what order they drew them out in, then I could just say I have 49 things and then separate it with a comma, taking 6 at a time. Look how it's scientific notation because the number is so darn long. So there's so many different ways that can play out that you have a way less chance of, I don't know, winning if the order matters, because there's going to be more different ways that it could happen. What else did I want to say? I wanted to say, if you look at the denominators here, because the permutations they're exactly, oh, you can't see, sorry. Because if you look at these two formulas, the only difference is the r factorial in the denominator. So if I divide this by a bigger number, it gives me a smaller outcome because I'm like dividing it by something bigger. So this one's going to have there's going to always be more permutations than there are combinations because you're only dividing it by n minus r, not n minus r and also this r. I don't know. I hope that was somewhat helpful. You are free to use Desmos for these if you want to.